All right, welcome to part two of getting started with the Mancala program. So we left off, we had just gotten the board displayed, and we'd said, it seems like it would be nice to be able to actually have some gameplay. So we're going to focus a little bit more on this play around method. Now, in our UML diagram, we already had a bit of pseudocode written out, so let's fill that in and see what we can do with it. It says if player's turn, if it is like the player's turn, if that's who should be going, then P turn. That way we're consistent with P board and C board. And then otherwise it would be the computer's turn. Boom. All right. And then player's turn, seems like it's a Boolean. And it doesn't really seem to be relevant if the game is over. I can check if the game is over either way. It doesn't seem to be relevant if I'm setting up the board because that doesn't really matter. It might be important to initialize whether or not it's the player's turn when you first start the game. So maybe there's some default value. But I try to tend to shift away from global variables or passing a lot of information around if I don't need to. So let's just say that the first time that we get in here, the player's turn should be true. And then after that, we just alternate every single time. But in order to do that, we still have to declare player's turn somewhere. And if we declare it in here, it's going to get reset every time. So I think we're going to end up being, oh, you know what we'll do? This will be easy. Let's pass it in as a parameter. This will be nice. All right, so it would say, in order to play the round, we need to know whose turn it is. Now, who calls play round? Mancala does. So play Mancala, and we need to play, determine if it's the player's round, and we got to keep track of it up here. So when we go to set up the board, let's just create this Boolean right here. Boolean play, let's say P turn equals true. Boop. All right. And we're going to do P turn. And every time we play the round, we want P turn just to invert. It's going to be swapping back and forth and back and forth. So right after we play the turn, we're going to say P turn equals not P turn. Done. All right, and what we just demonstrated here is exactly why we want to have all these methods that are really tiny, that are spread out, because inevitably code is going to creep into them. Variables are going to creep into them. So this play Mancala method that we had before that only looked like 3 lines is now up to 1, 2, 3, 4, 5, 6 lines, and now has another variable in it, and that's okay. But if we start with something a little bit complex, it's going to grow really complex. If we start with something small, it still grows to be manageable. All right, so that's taken care of whether it's the player's turn or not. Let's go back to play around. And I think I'm going to be consistent everywhere. I'm going to take this and make this P turn and then P turn, and we need to make that a Boolean. All right. Now, because I'm doing this after the fact, my IDE is not automatically putting this in, but I should put in a param tag now. Param P turn is true if it is the player's turn and false otherwise. There we go. All right. So if it's player's turn, take the P turn, otherwise the C turn. Now, why are we separating these two things out? Because a player's turn and a computer's turn are pretty different. Well, let's write these two methods now. Public static void, I'll steal from up here. A P turn. Boom. 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 And let's see, we'll do our block comment. Executes the player's turn. All right. And let's actually go back to our UML diagram for a moment and just think this through. So what actually happens when the player takes a turn? P turn. So first thing is the player, or we'll do, how about we select a pit. All right, so the first thing that you're going to do is you're going to select a pit, and baked into that, we're going to say, we'll make sure it's valid, make sure they're not collecting something off the board, make sure that there's actually stones in the pit. Then we're going to say, drop the stones. And I guess that's it, right? That's the end of your turn. Oh, and then you may be stuck in your turn. You may keep playing your turn if you ended in your store. So what we could do here, actually, this is going to be a really cool thing. We're going to do what's called a recursive call. We're going to say if you end in store, and I'll just leave that as a variable or some. We can probably just put the whatever the check is that we got to do in there. If you end in the store, then we're going to say, ready? P turn. You just take the turn again. So we call this same method. And again, let me make this left aligned so it's a little easier to read. All right, so what does it mean to take a player's turn? First, you select a pit, then you drop your stones, and if you end in the store, call the same method and you start the method again. And you can keep doing that over and over and over again. All right. And if you ended we are going to have some issue. This might be a special case where what happens if I end in my store and it's the last turn of the game? Now my game over is not checking. So I'm just going to put a little note in here so that what about last turn ending in the store? All right. I'm not going to solve that right now. There's always special cases you have to worry about. We don't design for them. We just consider them. And then if we have to revise code, we revise code. But let's get this figured out. So we're going to select a pit. All right. And then we are going to drop stones. And then, or let's do this. I'm going to call it drop P stones. So with the player dropping stones, the computer dropping stones will end up being a little bit different because of what store they can go into and can't go into, and whether or not you steal pieces. So we're just going to keep them separate with the anticipation that I'm going to have to do enough things different that it might be easier to have two separate methods. And then we're going to say if we end in store, and we'll just make that a variable for right now. We're going to do call p turn. Now the nice thing about this recursive call here is I've already defined the method p turn, so I don't need to define it again. And what I'm also going to do is I'm going to make this boolean end in store. I'm just going to make it false for right now to say let's not even worry about that rule because we're not worried at this stage about all of the rules of the game. Select pit. Well, when I select a pit, presumably I'm going to get a number back. It's going to say, which pit do you want to select? So I'm going to say int pit equals select pit. And then when I'm dropping the P stones, I'm probably going to need to know, well, what pit did you select? So I'm going to put that in right there. Or actually, no, I don't like drop stones. I want to call this execute P. Well, all right, we'll keep it drop stones. That's fine for right now. Because there is the part where I'm picking up the stones. I suppose we could do that right here and have another method. But I think I'm going to keep it just as dropping the stones and do it in there. And I'll tell you why when we get to it. So let's write these methods to get rid of our errors. Public static int, because we're going to be returning an int. Select pit. And right now I'm just going to write return 1 just so I don't have that error message. And we'll write our /star allows a player to select the pit they want to draw from, and then return the pit number. Now, here we have a question. Do I want the pit number as referenced by the person or the index right now I'm going to just use indexes to keep it simple. As an index. So that means 0 is the first pit, not 1 is the first pit. That's always something to be considering when you're dealing with human input. If I say select a pit, you might say, well, the first one, number 1, but I, as the programmer, know that's really 0, and I just got to rectify those at some point. Let's see. So I got my select pit, and let's do the drop p stone. So public static void drop p stones. Boom, boom, boom. And we got to do our block comment. Oh, and we take in a int pit, so we know where to start. Boom. And pit is index of the pit to start at. And here we'll put a decent description. So what we're going to do is we are going to remove all of the stones from, I'm going to call this pit index, just to be really clear about it. So we're going to say pit. I don't have to change it up here, but I'm going to just to be consistent. So we're going to say pit index is the index of the pit to start at. I'll remove all the stones from the pit at a pit index and deposit them one at a time according to Mancala rules until all stones are dropped. Now, what I just did here, I said according to the Mancala rules. That is my way of not having to write too much for this comment right now, and also acknowledging that there's a lot of rules to this game, and I'm not going to get into all of them right now, and that's fine. Later down the road, we can worry about dropping in a pit and having to steal all the ones from the. I'm not worried about that just yet. So let's, before we do anything else, make sure that we can actually run this game. I do have one error in here for C turn, so let's just copy this. All right, so that's one of the nice things about using extra methods is that you don't actually have to do too much work. So C turn, pit index, and then C turn again. Drop C stones, and then whoop, drop C stones and removes all the stones of the pit for the rules. And let's say for the computer, and we'll say for the person, for the player. All right. Do we have any errors? I don't think so. NetBeans usually gives me a little red line on the side. I don't think I see it. I didn't really make any major changes, but I'm just going to confirm that it's still behaving the way I think. And there we go. It's still in that infinite loop. I never end the game. I have no real human interaction yet, but we're going to change that right now. So let's go to the point where we select a pit. And I was just saying return 1. What we're going to do now is build into the game a pause. This is going to be an opportunity for the human to actually interact with the game and slow this down a little bit so it's not just this complete infinite loop. So I want to put a scanner in. A scanner is a way to look somewhere other than this particular program, this particular file for information. That could be another file on a computer, could be a keyboard. And a good habit would be to actually declare and initialize the scanner as a global variable so that you're not creating it over and over and over again in a loop in terms of efficiency. But I'm not worried about that. I'm just going to try to put it in quick and ugly just to get something working. So I'm going to make a new scanner object, and I'm going to scan the system.in. That's the keyboard. All right. And what we're going to do is right click here and say fix my imports. NetBeans goes ahead and finds that file for me. If I go to the top, it now says import java.util.scanner. And what we're going to do is let's put a little prompt for the person at the keyboard. Say select a pit. And then what we're going to do is say return instead of 1 sc.next int, whatever int they type in. Now I'm doing no input validation just yet. I'll come back to that. That'll be something we can do later. So I'm assuming the person's putting an int. I'm assuming that they're putting in one that is correct. That's fine. But I don't have any errors. Let's try running the program. And look at that. We don't have an infinite loop anymore. So it says select a pit. And if I type 1, nothing happens. It's not changing my program. If I put 2, nothing happens. It's not changing my program. But at least, at the very least, I'm getting to see some interaction. So what would be the next most important thing to change with my game? Well, I just selected a pit. Shouldn't I remove the stones from that pit? Well, let's try that. In our drop P stones, in our pit index, one of the first things we said we'd do is remove all the stones from the player's board at that spot. So let's do it. Let's going to do int. I'm trying to keep track of these stones. So I'm going to say int stones equal. Let me see. It would be p board square bracket pit index. So go to the player's board, go to the pit index location, and make all the stones, make the stones equal to that number. And then let's also make this equal to 0. I've just emptied it out. Let's see if that worked. All right, so I'm running my program. Oh, did I break my program? Let me see. There we go. Select a pit, so I'm going to select 1, and let's watch which one it actually empties. Look at that. The pit's now empty. The stones came out of there. It's my next turn. I select a new pit. If I do 0, oh, did that not work? Let's try that again. Oh, there we go. That time it worked. Oh, it just didn't. I just didn't actually enter it. Let's try 3. Oh, you know what I think's happening? I think I'm alternating between the computer and the humans. Let's go back and take a look at this real quick. C turn says select a pit, but really it's going to select a pit differently. So let's do this. Let's have select C pit and select P pit. So P pit for the player and C pit for the computer, because we're going to be doing those differently, right? So we just uncovered a little bug. Allows the computer so this is where all your AI is going to be. This is really it. It's this method. This is the method that is going to be your computer thinking and determining how to play. Allows the computer to select a pit they want to draw from, returns the pit number as an index, and I don't need a scanner for the computer. So what we might do for them is let's just say, let's have them return math.random times 6. There's 6 pits. And then we're just going to cast that back to an int. We're going to have our computer just randomly selecting a pit. So I select a pit, then the computer randomly selects a pit. And I just have to go back into where we do the player's turn, select P pit, and select C pit. All right. So far, so good. Let's see what happens. And we have this drop C stones. So if that is how we do it for the player, then presumably this, we do it for the computer. Let's see if it works. I'm going to run it, select a pit. I'm going to select pit 0, so it should be my very first one. I do that, and it's gone, but also the computer is gone in the same position. Now, it's supposed to be picking randomly, so there might just be a coincidence we took the same place. I'm going to go to position 1. I did it, and the computer selected that one next randomly. I'm going to select position 4. There we go. And the computer did one of theirs randomly. It looks like it's working. Awesome. But we're still not really getting gameplay. What's the next thing we got to do is actually drop those stones. Actually move them on. So right here, I have a number of stones in my hand. that is the number of times I need to drop a stone. And I also need to keep track of the position where I want to drop a stone. So let's make a loop, but we're going to make this loop a little interesting. We're going to say for int, and let's call it, we're going to call it the drop pit. Right, so that's going to be the pit I'm dropping into. Right now, it's going to be equal to the pit index plus 1. So if I said take something out of pit 1, I'm going to start dropping in pit 2. If I say pick things out of pit 3, I'm going to start dropping in pit 4. Now for the computer, it's going to be the same logic because we printed the array backwards, but we're actually storing it forwards. So we're going to end up having the same logic there. So make my drop pit, start there. How long do I need to go? Well, I need to count up until stones, or all my stones are gone. I can just use stones as my counter and say, while stones is greater than 0, and what I'm going to do is each time I'm going to say stones minus minus. All right, so what do? Well, I go my P board, and I go to my drop pit location, and I'm going to add to it 1 stone. Now, I don't need to do a subtract in here from my hand because that's already being done in this for loop. Let's see how this works, or if it works. All right, so select a pit. I'm going to select this 0th pit, so I should expect a 5, 5, 5, 5. Let's see if it worked. It did not. Why not? We didn't increase our drop pit. So up here we said stones minus minus, and that's getting us closer to our condition statement, but we never changed our drop pit. So let's do that in here. Drop pit plus plus. Now the nice thing about doing it here is this is not going to be actually this simple. We also need to consider, well, what happens when I get around to the end? Now I got to start dropping in the computer side, and then if I get all the way around again, I'm going to have to start dropping back in the player side. So this is going to end up getting a little bit nasty. In fact, there's a pretty compelling argument for using one single array to store all the players' stones and all the computer stones. That helps make it easier to do this like kind of wraparound. But we made our decision for 2 arrays. It's a decent amount of work to go back and change that, so I'm going to try to keep going forward this way. So we'll do our drop pit plus plus for now. Let's see how this works. We're going to stop the run and start over again. Select a pit, 0. All right, now my 5s all look good. And the next thing we're going to do is then, I guess, we'll try another pit. So let's take pit. Let's do this one. We'll do so pit 1, 0, 1, 2, 3, 4, 5. So index 5 is the one closest to my store. I do that, and here's my problem. I get an array index out of bounds error. So I went into my store. I still have more stones left. I kept trying to go forward. You can't do it. That spot doesn't exist. So now what? What are we going to do? Well, we have to get over into the computer's board. All right, so we probably have some exit condition on this for loop, or we got to make a more interesting loop. And we could try to make a really complex, interesting loop, but I'm just going to have an exit condition. So I'm going to say, if you have no stones left, exit, or shouldn't do that. Wait. Or let's say swap. I'm just going to make a Boolean swap. Boolean swap equals false. And the swap is just going to tell me, or let's call it wrap instead. I don't know, wrap around. So I'll keep it swap. But I wanted to have some kind of variable that's telling me, hey, I'm switching from one array to the other array. So for int equals drop pit index plus equals 1, while stones is greater than 0, or if swap is true. Oh no, actually, I want this to be. I really want this to be the opposite. Or if not swap. If I haven't swapped, I'm still here. As soon as it becomes true, now I'm into a different loop. I'm going to put another for loop here. And this for loop, if I still have stones left, is going to say, well, swap back. And I'm starting to think now, maybe I'm better off with a while loop. That's going to say, while I have stones, let's just keep dropping them, but I need to keep track of which array I'm in. So let's try doing that. Let's start over. I'm going to bring all this stuff down a little bit. And I'm going to instead say, while stones is greater than 0, I'm looping. I'm dropping stones. Let me see. Oh, you know what we could do? This might be better. I'm going to say, instead of having a Boolean that flips back and forth, I'm going to have an int array reference that's going to say my cur array. And right now, my cur array is my p board. I'm going to start in my p board. Then when I swap, my current array will swap over. I'll just force it to be the computer board. And then if I swap again, it'll go back to the P board. So I'm always dropping stones in my current array. And that will be the thing that alternates. I still have this drop pit that is going to start out. So this is before my loop. My drop pit is equal to the pit index plus 1. Perfect. And then I'm still going to say this line, the only difference is instead of it being my P board, it's going to be my cur array, which in this case is my P board. But I'm going to say, hey, add 1 to the current array wherever I'm at. Then here's the important part. I now need to check. So I'm going to increase my drop pit. I need to check if I went too far. And I also need to decrease my stones. So as soon as I do that drop, I'm decreasing my stones by 1. I'm adding to my drop pit, and now I'm going to say if drop pit is greater than, let's see, the length of my current array, cur array dot length, then I need to swap arrays. So let's say if it's greater than the current array dot length, oh, you know what I'm going to have to do? I'm going to end up having to do this twice anyhow, because I'm going to have 2 different if statements checking to say, do I go to my computer board or do I go to my P board? But also, my computer board is actually a little bit smaller because I'm not going into the computer store. I'm skipping that one. So I'm going to say if the drop pit is greater than my P board length, and drop pit was, oh boy, this is going to get to be a messy method already. I'll tell you what I'm going to do. I think I might just not worry about the wrapping for right now, because I don't want to have this this video just be a 20-minute video of me doing this particular method. But this is going to be your most complex method other than the AI for the whole program. Everything else is going to be pretty straightforward. So let's look at where we're at, and let's get this to a point where we can walk away from it and say, that's pretty good for right now for our basic program. So we have our stones we're getting from the board. And actually, you know what we might do is, instead of having 2 different drop methods, maybe we just make them one and the same, and we have some kind of Boolean keeping track of whether we're the player or the computer. So I think this is a method I really want to give some thought to, rather than try to just rush something through. So we'll get it happy and working good enough for now, but then we'll probably come back to it and really revise it. So let's see, we got our stones, we have our pit index, so we remove our stones from that place. We're keeping track of the current array we're on, which starts at the P board. Our drop pit is going to be the pit index plus 1, because we're always going up 1. While I still have stones, I'm going to go to that particular pit in my current array, add 1 to it. I'm taking the stone out of my hand. My drop pit increases. And then what it'll do is I'm just not going to worry about the case where I double wrap. So I can wrap from the player board into the computer, and I'm just going to not worry about the case where I have like 12 stones piled up and wrap back around, because that is where it'll start getting messy, and I really want to design this in a sensible way rather than just add if statement upon if statement upon if statement. So we're going to say if the drop pit is greater than the let me see, pboard dot length. Right, so if we're getting too big, or actually, if the drop pit is 7, the pboard dot length is 7. So if it's greater than or equal to the length, because a 7 index is actually beyond the board, right? The length of the board is 7, the last index is 6, or the length of the board is actually it's a 7, and my last index is going to be 6 is the store, not the pit. But if I have a 7 as my drop pit, I've gone too far. So if the drop pit is greater than or equal to the pboard.length, what we're going to do is swap the arrays. So I'm going to now make my cur array is equal to the cboard, and my drop pit goes back to 0. It's going to be 0 on the cboard. So we're going to start there. And let's just see if that is honky-dory for the time being. So we're going to run it. We're going to select a pit. Let's start out with pit 0. And we'll just test that and make sure it works. And it looks like it does. And now let's take this 5 right here. So if it's working, I should get a 5, a 1, and then I should get a 1. Oh, well, the computer's going to have a turn also. But I should get a... oh, no, the computer won't have a turn yet. So I'm going to get a 5, a 1, a 1, and a 5, a 5. And that should be it. So let's see if it works. That is pit 0, 1, 2, 3, 4. So pit 4. Hey, look at that. I got my 5, my 1. It wrapped around to the 1. Now this became a 0, but I think that's because the computer actually picked that 1 and started moving with it. So it looks like we're moving and working. That's pretty good for now. I could copy this and paste it into the drop C stones for right now and just tweak it enough that it would work for the computer as well. But knowing that I'm going to come back and change, I'm not going to spend too much time fiddling with it. So let's make this cboard, 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 and then cboard and keyboard. So that should have done all of us. So now we should be able to see the computer playing. Let's see if we got our computer playing. So we're going to run it again. Select my pit. I'm going to pick, let's do 0 again. I'll be my first move. And hey, look at that. The computer picked here and he went around. I'm going to pick a pit. Let's do 3. Look, guys. The basic program is done and working. It's not great. It's not pretty, right? It's just a text-based game right now. But we've gotten the basic functionality working. I know we don't have a lot of the gameplay working. It's not allowing me to steal stones. It's not checking if I've landed in my store and get to play again. It's not doing a double wraparound if I get a big number. But all of that is stuff we layer on later. What I've done, though, is I've given myself a really good structure where I can go back and and add any kind of features or make any kind of modifications I need to. And then we'd also go back and clean things up that we found out we maybe didn't need. So like this initialize players ends up don't even really need that method. So let's take that out. And I can take that out from my setup board down here. My fill board method I did right. I think that's still working. Everything else looks like it's pretty good. So, it might be nice on the C turn. Let's see, when the player picks, I'm going to have the computer tell me what it picks. So I'll say system.out.println. The computer picked pit index. All right. And then what we can also do too is if we wanted to get rid of some of these testing lines, we just drop them all out. So I'm actually content just to delete them at this point. Sometimes I would leave them in and just add comments. Not worried about that. Oh, the game over we have not done yet. That is something that we can do that won't be too difficult. All right, but let's get all these print statements out of here. And we'll do another quick test to see how this looks. Because now my gameplay should be a little bit nicer. So we'll end the game. We'll run it again. All right, there's the board. Select a pit. I'm going to select pit number 0. All right, here's the updated board. And then it said the computer also picked 0. Well, there you go. I'm going to pick, let's do 5 now. So I'm going to do a wraparound run. And there we go. The computer picked 1. All right, so it's working. But the game's not going to end. And actually, we can keep... Oh, you know what? We're eventually going to get an index out of bounds there, I bet. Let's just keep... I'm just kind of picking things haphazardly and randomly. I'm not really... There we go. There's my index out of bounds. So when I get too big and I do the double wrap, that's where we run into a problem. So that's the only way to end the game right now. We could write our end game method, though, because it's actually not too bad. I think we did this one in class. So game over. The game is over when either or both sides of the board have no stones left in the pits. So let's count up how many stones they have. So I'm going to get the an int C total. We'll call it C pit sum equals 0 to start. And we'll say int P pit sum equals 0 to start. And let's count them up. 4. Int I equals 0. I is less than P board dot length minus 1 because we're not counting the store, even though the store is an array. I plus plus. And we're going to say the C pit sum plus equals C board at that particular position. So we're adding whatever is in the board at that position to this sum. And we're going to do the same thing with the player. P board and P pit sum. And then we're going to say if, we did talk about this, you don't really need to use an if statement here. You can just return this boolean statement. We're going to say if C pit sum equals 0, or if P pit sum equals 0, that means the game is over. Return true. Otherwise, return false. So we don't actually have to write otherwise here because you're only going to get to this return false if that's not true. But I think it is good practice to just be really explicit about what you're doing. In fact, you don't need these curly braces, but again, I think it's good practice and good stylistic norms to do that. So now we have a working game over program. This is truly a working Mancala game for like the basic version, other than that double wrap. And that double wrap is something that we can work on together. But again, I hope that you found this helpful, and good luck with it. Peace.